Hey there students, welcome back. Today we're going to do 10.2.4, and within this lesson we're going to determine how many solutions an equation could possibly have. All right, so let's just jump right into this. So far in this course you've seen many types of equations, some with no solution, some with one solution, others with two solutions, and still others with an infinite number of solutions. Is there any way to predict how many solutions an equation will have without having to solve it? We're going to focus on this today. So 10-60 says, in prior chapters, you know that some quadratic equations have no solutions. Some will only have one, some will have two. How can you quickly determine how many solutions a quadratic equation has? So the equations below are quadratic equations in perfect square form. Okay, we're going to solve these as quickly as we can, and we'll determine not just what the answers are, but if you guys can notice the pattern, especially among those that have no solution or have one solution. Okay, so let's just do the first couple together, and then I'll have you guys do the other four on your own. Okay, so look at problem A. I have the quantity x plus 4 squared, and it equals 20. So to get rid of that second power, I've got to undo this. The inverse of squaring is square rooting. Okay, so I'm going to square root both sides, and that gets rid of my second power. Right, so I have these positive and negative square root of 20 now is my answer on the right so far. Okay, and then my next step, I just subtract 4 on both sides, and x equals negative 4 plus or minus negative 20. So I technically have two answers, right? I have the negative 4 plus square root of 20, and then I have a negative 4 minus square root of 20. So this one has two solutions. Okay, we'll do the same thing with problem B. Set up the exact same way. I'm going to square root it to undo that second power. I get 7x minus 5 equals, I have the square root of a negative 2. All right, so this one is a little bit tricky. I'm not going to solve this one all the way because at this point I know I'm not going to have a real solution, right? But I'll just solve it just so you guys can see what it looks like. Okay, so the plus and minus square root of a negative 2. So I'm going to add 5. Usually I like to write that plus 5 right there, but I'm out of space. So last step is to divide by 7, and x is finally by itself. X equals plus or minus square root of negative 2 plus 5 all over 7. All right, so at this point I want you guys to pause the video and do the other four on your own, and come back when you've got an answer. All right, so for problem C, square rooted 49 on the right side, and that gave me a plus or minus 7, right? So then I'm going to add 3 to both sides and then divide by 2. So my answer is 3 plus or minus 7 all over 2. So 3 plus 7 is 10. 10 over 2 is 5 would be my first answer. And then 3 minus 7 is a negative 4 over 2 is a negative 2. So those would be my two answers technically. Okay. For D, when I square rooted both sides, I got the square root of 0. Square root of 0 is plus or minus 0, but there's, you can't have a plus or minus 0. So it's just 0. So you only have one solution, and this one solution is 1/2. Okay, for E, again I have square root a negative number, so I've got no real solutions. And then for F, I have to subtract that 5 first on both sides, and 5 minus 5 gets me 0, and because of that I only have one solution. It's negative 11. So what can you determine? What's the pattern here? Do you guys see a pattern? Let's excuse me, walk you guys through this. So when we have it equal to a positive number, I'm going to get two different answers. So two solutions, right? So look at everything that has a positive value on the right side. Okay, we've got two solutions. When it equals 0, every time it equals 0, I have one solution, right? Equals 0, one solution. And then every time it equals a negative number, I have no solutions. Okay? That should have been the pattern that you could identify. So, moving on to 10-61, we're going to use those patterns again and quickly determine how many solutions that each problem will have. It says you do not need to solve the equation. So don't solve it. Just real quickly, pause the video, figure out how many solutions this has. If you understood that previous problem and identifying the patterns, you could probably do this in less than a minute, probably less than 30 seconds. All right, so pause the video, come right back. Okay, for problem A, you got to make sure we get rid of that positive 6 first before we can determine, right? So this one could have been tricky if you just went through it real fast, because you thought maybe you saw that 0 and you thought this would be one solution. But we've got to get rid of that positive 6 by subtracting 6. Because we subtracted 6 on both sides, on the right side I get negative 6, therefore it's no solution. For part B, I have it equal to 0. That means when I square root it, I want plus or minus 0, which isn't going to change my answer. I only have one solution. And then part C, I have a square root of 11 when I start solving, and that's going to give me 2 solutions. All right, let's move on to the next one, 1-62. It says, what if it's in standard form? Right? Ax squared plus bx plus c equals 0. How many solutions is this going to have? So they give you an equation here, and it says to write the solution in both the exact form and the approximate decimal form. So I would recommend solving this equation right now using the quadratic formula. Okay, so pause the video, solve this quadratic equation in part A using the quadratic formula. And come back when you're done. Alright, so after plugging everything into the quadratic formula, I got 2 different answers. First one is 1.3, the second one is 0.19. So that's in decimal form. If it's asking you for the exact form is before we actually punch it into a calculator and got the decimal, right? So as you can tell, we have 2 real answers, right? They're decimals, they're not pretty, but they are real numbers, they're not imaginary numbers. So part B says to change the 1/2 in this equation to another number that will give us no real solutions. What would be that third term, that C value? What would it have to be so that there's only one solution? Okay, so think about that. Pause the video, come back when you're done. Okay, so hopefully you thought that in order to get one solution, this entire part of your quadratic formula has to equal 0, right? As we've been practicing, once you add or subtract a 0, it's not going to change your final answer. So in order for us to get 0 in here, this term has to equal 9, right? Whatever term that is, it has to equal 9. And what affects that term is going to be over here. It's that C value. So it's asking you, how can you change that C value so that that whole part equals 9? So let me just write that whole part. I have 4 times 2 times something, and it has to equal 9. So we'll just call that something x. So we have 8x equals 9. Divide both sides by 8. That C value has to be 9/8. Okay? And moving on to the last part here, it says, how can you tell from the standard form whether the equation will have 0, 1, or 2 real solutions? So basically what we just talked about, everything inside this part, the square root part of your quadratic formula, has to equal 0 for it to have one solution, just like what we did here, right? This is called, and I've talked about it in the past, there's a word for this special part in this this square root, this radical. This is called the discriminant. It will tell you how many solutions you have, right? So if that discriminant equals 0, you're going to have one solution. If it equals, oh, excuse me, let's backtrack. I'm misreading this. If it equals 0, it has one solution, okay? If your discriminant equals 0, so I'll write equals 0. If your discriminant is negative, if it's negative, it will have 0 real solutions. And if it's positive, it will have 2 real solutions. Okay? So write that down if you don't already know that. All right. Let's move to the next problem. So again, for these two problems, it's asking us how many solutions does it have? How can you express the solutions? How can you write it out? So real quickly, I want you guys to use the discriminant to tell me how many solutions each one of these has. Pause the video, come back when you're done. Okay, so for problem A, since it's in standard form already, I just put in the discriminant and I solved and I got a positive 232. So if I got the square root of that, I know I'm going to have a plus version, a positive version, and a negative version, therefore it's 2 solutions. For part B, it's already in perfect square form. So technically y equals 0, right? Because that's how we solve for x, is when y equals 0. So if I start square rooting this, well, again, you'll see that the square root of 0 is 0. So when I solve for this, I should have one answer. Hold on one second. Okay, yeah, so if I know once I start solving this, I'm only going to get one solution because you can't have a plus or minus square root of 0. You're only going to get 0. All right, so let's move on to 64. And it says to check the work with the graphing calculator of part A. So let me show you part A. I've already put it on Desmos here for you. You can tell that I have 2 solutions, one right there and one right there. Okay. 65 has an absolute value equation. So if you recall, absolute value of equations, we're going to have 2 different solutions, right? So once we start solving for this, because the absolute value is essentially saying, if I'm solving this, what numbers are going to be 9 spaces away from 0? Okay, so you're gonna be able to get 2 different answers for this. So if you recall, when we're setting this up, I'll write it down at the bottom. I have 2x minus 5 equals 9, and then I have to do 2x minus 5 equals the opposite of 9, which is a negative 9, because I want 2 spaces, or 2 different answers that are 9 spaces away from 0. That's what absolute value means, right? Distance from 0. So go ahead and solve, or we'll solve this together because I know you guys can do this with relative ease. I'm going to get 7 is my first one, and then this time I'm going to get a negative 4 on the right side, so my answer is going to be negative 2, right? So this is, can an absolute value equation have no solution? Create an absolute value that has no solution. How can you be sure there's no solution? So with that in mind, I want you guys to pause the video. You're going to do this part on your own. How can we change this equation, or what is the equation going to look like when it's absolute value for it to have no solution? Okay, pause the video and come back. Okay, so hopefully you did some thinking about this. Let's go back to the original equation at the very top here. So for an absolute value equation, like I just explained, it tells me how many spaces it's going to be away from 0. What's the distance from 0, right? So for us to have no real solution, all we have to do is have this be a negative number. Okay? Because there is no way you can get a negative distance. So anytime you have an absolute value equation where the absolute value on the left is all by itself, there's nothing else next to it outside of those bars, and it equals a negative number on the right, it's saying you're trying to solve something that has a negative distance. Well, it's impossible to have a negative distance, so therefore there's no solution. Okay, all you got to do is make that number on the right side, the other side, negative. Okay, so for part C it says, well, now create an equation with an absolute value that will have only one solution. Only one solution. Okay, pause the video, come back when you think you have an answer. Okay, so hopefully if you've determined that if it equals a negative, there's no real answer. If it equals a positive, there's two real answers. So then all we got to do is make it equal 0. If I change that value to a 0, it's only going to have one real answer, because when I start solving for it, I'm going to set it equal to a positive 0. So for example, this would be a positive 0, right? I know it doesn't make sense, bear with me. And then the other one will be a negative 0, which there's no such thing. It's just going to give us the same answer every single time, and that answer would be positive 5/2, right? All right, so that is it for today. I do want you guys to, if you have time, look at the learning log question and just answer that first question, okay? How can you tell without solving how many solutions a quadratic equation has? All right, that's it, guys. Have a great day, and hopefully I will see you soon.